Good afternoon, everybody. Do I need to use the mic? So I guess I will so people can hear me in the back. Hi. So I'll let people kind of wander in as they end the session, as we begin the session. So my name is Jeff Jenkins, and I work at Presence Product Group. The obligatory spiel is that we're a dev consulting shop, and we make fancy things on the internet. Data visualization and large-scale web applications is one of them. So today we're going to talk about D3 and the kind of experiments that we do for our clients, financial institutions in particular, and how we use it to solve some basic problems. And some of the more advanced things are going to talk about is how to actually to make data actually have a message or be able to communicate something that's beyond just a simple graph. So what are you going to learn? Today you're going to learn two things. I'm going to try to explain something simple and something a little less simple. The simple thing is just how to use D3 to get off the ground. How many of you have actually heard of or used D3, ever like downloaded the library? Sweet. So today I'm going to try to profess that I am no absolute expert on D3. But what I am is someone who has built it in production applications, and today I'm going to try to reveal some of the pitfalls that we've had implementing it, how we got it to work well for large applications, and kind of the methodology that we approach and when we put it in applications. The less simple thing is we're going to actually, and what the title of the talk is how we used it to produce visualizations that weren't just the things you get off the normal website, actually building things from scratch. Visualizations for interacting with data. In this particular instance, we're gonna use an example for how you can view a portfolio and how you can look at and rebalance portfolio. It's a much scaled down, simplified version of something we built for another client. There's going to be a few code examples. So that's the agenda for today. So let's see if we can get through this. So everyone knows that D3 stands for document-driven data, and that's kind of a lot of people approach D3 when they think visualizations and the idea of something of what D3 actually is. And I was kind of surprised to learn when I first started creating D3. It is just a DOM manipulation library. It shares that in common with jQuery. It manipulates div elements, paints them on the page, and has a set of models and has selectors for moving things on the page. It can actually replace jQuery on some website. I know of a production application where it does that. But where it really shines and what we all know it's good for and what we're all really familiar with when we look at like really fancy examples like this, things flying around on the page, this is what most people approach it. But it is just a way to take data and paint div elements in a really structured way. So you can make really cool and fancy visualizations, but doing that we found out is building scaffolding from the ground up, one section at a time, and being really methodical about how you put your apps together. So when we were first approaching D3, we had a specific client who came to us with financial data, and they wanted to view they had some basic simple requirements. They wanted simple graphs, and they wanted them inside an Angular application. And when we first approached this, we didn't quite know whether D3 was the right choice, and we really had to sit down and go, well, if you just need visualizations, what's the best library to solve the problem? And when we approached that, we kind of listened to the client. And this is kind of when first approaching any library, going and saying, what kind of product am I trying to build? And how is that product, and how is this technology actually going to meet that? And I mean, they needed two basic things when we were building this first application. They needed the simple thing, which was they needed a widget library. Not rocket science. They needed some basic graphs, and they needed them painted on the page. And the second thing is but there was a couple nuances. They needed those graphs to have more usability. They needed people to be able to drill into the widgets, and the big thing was it was a library. And they didn't quite know what kind of visualizations they were going to need in the future. They had some basic ones they told us about, but what we eventually got, and very quickly on in the conversations, and as anyone knows, as you talk to your product manager or you talk to the stakeholders, client requirements evolve, and to figure out that they needed to take portfolio data and not just graph it, but actually have people drill down into data in a graph and be able to view things with different perspectives. So they were talking about things like portfolio adjustment, which just the basic idea of I have target allocations for different asset classes. You know, I have tech stocks and this, and I need to be able to see what they currently are versus what they will be. They also they had some more risk data they wanted to overlay. So they had two sets of data that they wanted to overlay on top of each other. But they didn't quite have clear requirements of exactly what this wanted to look like. And it just kind of shined about why D3 came through. Because if you have requirements, we're going to need to build custom visualizations. And you need things like fast load times. You have you have customizable visualizations like axes, tick marks. You're going to have overlays. You have things that a standard graphing library might not have exactly what you need. And you need something that can extend with it and, of course, is well documented so you don't have to, and you have a community you can fall back on to be able to ask questions about how to solve what you need to get solved. So when we were looking out there, we kind of saw three basic types of data visualizations. Everyone's like familiar with Google Charts. It has dials, pie charts, the basic things you'd need for an application. And we also knew that when we saw it, we found some solutions for some of the kind of the visualizations that they were asking for, the product needed to have, like more boutique solutions. There are things like High Charts has financial visualizations that are like boutiquely built for specific applications. But when we looked across these two other alternatives, we were like, well, it's kind of the Goldilocks problem. One, the Google Charts are great, they're really fast and work well, but they don't quite look and feel like we need them. They're kind of an a la carte. You take them or you take them for what they are. High Charts was just impossible while it was really powerful, actually reverse engineering it, trying to make it do the kinds of things you need to do, or mixing those other things was quickly we figured out would take more time than actually building it from scratch. And that's kind of like once you've tested that idea, those two ideas, you come back to the basic. Kind of a basic realization. If you want visualizations that are going to have the requirements that we were talking about earlier, you're going to have to build them from ground up. And that's what D3 is. It is scaffolding. It is building blocks to create visualizations from one section or one particular from the ground up. And if it's done, and if you follow the patterns on the website, on the examples, and lots of great and the great resources that Bostock has on his page and on the GitHub page, you can cumulatively build on top one section on top of the other. So I was kind of daunted when I first started doing this, and I quickly found that if you follow the best practices, it really does read like a book. And you can create simple visualizations and use that foundation to spring forward and and once you start getting into more complicated things, those patterns really come back to pay dividends. All right. So why we chose D3 is, well, as I said before, we didn't know quite what kind of visualizations were going to come down the road, and each thing can be tweaked. And because you are literally building interactions on top of each other, you are painting the actual div elements, DOM elements in an SVG. You actually don't have to use an SVG if you want. It'll manipulate any kind of div element. But obviously, SVGs are ideal, or what most people use it for. You can take each particular part of your visualization and really tie them all together so you can layer things on top of each other. So the tech side of D3, some of the reasons we also chose it that the client was aware of, it is responsive. And by that, I mean that you can scale the actual visualizations and re-render them, and they work very well on tablets when you have different portrait and landscape modes for realignment. And a lot of the other applications that we were using crashed the browsers ferociously. HighStock was particularly bad. But no offense if anyone works on the HighStock team. It's a great product. But that is part of that scaffolding idea that I keep coming back to. You can do as much or as little as you want. And on mobile, we all know less is really more. Faster load times and not crashing the iPad or WebKit on the iPad. And being able to scale back and create, like when we had 10 plus widgets on a page, having just a few lines of code and only painting those elements we really just needed for that page was ideal. I should have mentioned from the beginning, if anyone has questions in medias res, just raise your hand and I'm fully up to make this more conversational if anyone has any questions. So as I've covered before, you can customize anything, and the community is awesome. Like Stack Overflow, people get back to you incredibly quickly. It's really nice how passionate people are about getting up and showing showing off how smart they are, because those quick response times are, they've saved me many a time. All right, so it's part one, basic idea of like how we approach D3, why we chose it. I think most of you in the room are a little more experienced than a normal crowd, so this probably was review for most of you. But so now I'm going to go through and try to, like, the first part, try to show how we set up the patterns for making a basic basic stacked area visualization. And everything I'm going to show you was placed inside of an Angular directive, but I'm not going to get into that level of detail. The code it starts off pretty simple, and I'm trying to walk through it, but it gets it's a lot of reading for a presentation. So I'm going to try to hit the high points and kind of show how you can build cumulatively one step on top of the other, and then keep referring back to the patterns and the singletons and the things you've created before to be able to structure your application. So step one, document visualization, is the data. So I'm going to when we started off, one of the first visualizations they really asked us for was just a basic visualization with data for different trades. This was live data. I have no idea why they calls it close 3. They have lots of weird names for their data. But this was one of the first passing off points. So they just wanted to show 3 basic portfolios at different positions, and they wanted them painted on the page. So when we looked at the data, the first step was getting a handle on what kind of visualization. And whenever you start, the first thing is the actual view area. Setting up the margins and the proper tick marks is really instrumental. I neglected doing this correctly in the first step, and it really comes back to bite you. Setting up the margins, placing your axis points in there is incredibly important for getting things, for getting your visualizations right. And we've probably all seen this 1,000 times. There's just basic steps of code. There are basic steps of code. D3 has this is like straight off the Mike Bostock margin convention. But it's kind of the first step for beginners is once you start setting up these margins, everything you do is going to be based on these variables and these positions, because everything's absolutely positioned, or it's in an SVG. So everything's going to be painted on top of each other. Div elements float in this realm where everything is based on X and Y coordinates. So everything that you paint in there, every time you put a label or an axis, is going to have to refer back to the margin variables. And setting the width and the height of your canvas is absolutely instrumental. And it sounds trivial, but when you start trying to work with interactions and painting multiple levels of things happening on the page, and labels that are actually not in the sides of your graph, but actually inside of it, making sure that you have these basic spacing set up correctly, so you always have these very obviously named variables where okay, this is where the margin starts, this is where this graph begins, especially if you have multiple graphs on the page that are going to be placed. Like if you have one graph over here and one graph over here interacting with each other. For this example, we're just going to have one. It's going to be fairly straightforward and simple. So as you can see, there's tick marks and labels, and the code reads pretty dynamically. D3 has great helper functions, great methods for setting up axes. It actually takes your data internally. So I'm just passing in this. All this is doing is passing in a div and a data from my presentation, and this is the actual div container, and here's the data that's just being pulled from a JSON file that you can see down here. So we're setting up some simple formatting of the data to turn it from JSON into numbers, setting up the axes, selecting actual div elements, and then just painting the axes. And these axes can be, what's really cool is once these are set up, you can go back to them and refer to them later. So if you want to change axes or change the way they're viewed as the data changes, it's really, I wouldn't say trivial, but it's a lot easier than having to go back and repaint. You can just call these axes, put something new in, and they will change magically, as we'll see later. So I've already kind of got ahead of myself. Labels and legends. Everybody remembers math class when they first taught you about graphs. The first thing that teacher said is labels are the most important parts of graphs. And I hate to admit, but she was right. So actually getting labels to be painted correctly on your graph is ties directly into the idea of margins. Placing them, and as you can see, like when we paint them in this, you can actually see that we're using an attribute, we're using the margin left and margin top attribute to actually place them slightly left of the actual painting area where we're going to be putting things in the actual DOM. So cool. We have a place to put our graph. We have a place to put our stuff. We have our data scaled. We have, and as you can see from the previous example, we have the values that were actually in there. The max and mins are set up. So, but that just kind of seemed to magically happen, and that's because D3 automatically scales things for you. Well, it doesn't automatically. What it does is it has methods that tie directly into the x-axis and are reused over and over again to take your data, find the high and low points for your x and your y-axes, and properly talk for your data and properly talk to the other components, so that when, instead of you having to methodically paint the individual elements you need, or the individual elements for x-axis, they're just painted for you. So you can see that D3 has an automatic time scaling and linear scaling function for components. We just pass in our range and our domain, and we use a handy max function to find the maximum value of our data. And it will set up these domains. And a range and domain is a very simple concept. It's just a range is a height, max height, or a range is something that will be the output, and the domain is the input of the data. So you can tell it, I want to go from.
Zoom into the code.
Oh yeah. That's. How about in the back? Question. Sweet. So, scale, it's important, because everything you do is based on it. If you want things to be painted in the DOM in the correct space, everything you do has to will touch the scaling, will touch this scaling function. Calling them X and Y is a pretty standard method. People also call them X scale and Y scale. Naming convention starts to become very important when you start having these multiple interlapping components. Naming things in a predictable way, and actually what they're doing, not only for what they're doing, but how you might have multiple versions of it, becomes incredibly important. So remembering that these are your scaling functions, these are your axes, and then as you might have different scales for different types of data, labeling them for what they are and how they reflect your data will save you so much headaches, especially if you're working on a team. And if it's really done right, what should happen is the code should kind of read like a book. So I'm a fan of setting up these variables over and over again. A lot of people think that's bad. You should declare all your variables at the top. Actually, declaring variables just when you need them in D3 will keep you somewhat sane, because every time you trying to keep things like when you declare when you call methods that you're going to need and these objects are produced, making them exactly where you need them and then using them right away can make your code a lot more readable than trying to declare everything up top and get what you need, and then trying to constantly scrolling up and down or flipping back and forth to refer to where you declared something and actually where it was placed in the app. So that's colors and contrast. So we're a little out of order. So I'm gonna skip to this graph right here, which is the actual implementation of a stacked area chart, which is just taking that simple data that we saw in the JSON file and was here, and it's just simply painted on the page. So to actually get, you can see we have like a couple basic components here. What we have is we have two pieces of data on top of each other. We have multiple plots. So here's our 3 plots, and then you can see they're grouped or categorized in an individual section, and they have color coding. So I'm going to kind of walk through some of the components here of how we're using this. And this is the point I'm going to kind of get a little hand wavy, so feel free to stop me because there's a lot more. Quite a bit of code, code to cover, and but all these examples will be online, so you can refer back to them and look at them. I mostly just do a lot of linking to some of the other patterns you can see on other sites. So, colors and contrast. So D3 has a built-in color module. So I think this is one of the coolest parts of D3, in my opinion. D3 will automatically assign colors based on specific ranges, and it has some pre-built-in color, like pre-stock built colors built into it. So it will choose colors for you as your data grows. And there's all sorts of conventions you can find out there for people who've provided code for you. And what happens is, as you feed your data into a particular, as you feed your data and it's rendered in the actual app, as you actually paint it in the div, you can actually apply a simple fill in the CSV and call this color method that you've checked out. And each time all you have to do is pass in what order it's being painted in the div as your data is iterated through, and a color will be automatically chosen. When you set this color object up, you can actually define how you want it to render, what colors it can choose, or what colors will be predefined in it. So when you're trying to actually make a point and contrast data, and you don't quite know how large or small your data is going to become, this is an absolute lifesaver, because actually having to hand code or just find large color libraries can be a real pain. So adding a second plot. So I'm gonna go over here to the initial plot, because actually my graph, to be honest, my graph isn't working over here. And I'm going to walk through the actual how we pass the data in once we format it, and actually gets painted in the div and the colors are selected. So we're selecting the SVG element after we set up the margins, and at the very bottom we're creating a stacks object. So because this is a stacked area graph, it's a little more complicated than a normal area graph. D3 has a stacked API built into it. And this is a really good example of like a basics of a lot of like the handy libraries that D3 has. And all it does is you feed in a line of data, you feed in an array of data to it, and it formats the data. So instead of it just being one area graph overlaid on top of each other, it calculates a bottom and a top for the actual data. So where it should start painting and where it should stop on the y-axis. So you can see we have two basic portfolios. We have the first portfolio from our data, which was industrials, and the second one, which was tech. And what it's going to do is it's actually taking these two data sets and it's just dividing them and painting them in an X and a Y. So what's the actual result of this entire long stacks is it simply takes a map section of your data that's taking names and the actual Y values, and the actual stacks object that it passes out is a formatted piece of data that when you go over, define your area object, and actually paint in the stacks, which is the actual formatted data, what you get on the outside of this is actually it paints two SVG elements, one on top of the other, properly positioning them line by line. So having to actually hand code that or do it yourself is possible, but like helper methods like this make life so much, methods like this make life so much easier when you're trying to create visualizations, because little simple things like this can actually become way more complicated, especially as your data grows. You go from this example has only 3 plots in it, but this actual graph, when it was implemented, will have thousands of plots in it. So just for the sake of simplicity and like so we can look at it. And wrap our heads around it. So as this grows and as we have tons of new colors, tons of new data points, being able to actually have these methods be able to handle that amount of data is really important.
Sorry, are you saying that you do not have to do anything different to handle the greater data set?
That is a hope.
But I mean, that was your last point was you were showing three data points, but you could use that same presentation code to show greater numbers of data.
Correct. So I mean, that is keeping your mind around how data is formatted, how your JSON's formatted, and the eccentricities of your data. Like especially with us, because we were pulling from live data in an Angular app. We don't know. One day it could be in the thousands, and the next day it could be in the tens of thousands. And properly scaling and selecting colors is what's really important. And the reality is you're never going to know when something's going to break. It just happens. But it's following patterns in that where you efficiently paint and follow the standard stock like follow some of the D3 patterns that are like pretty well documented, will make sure your app has a much higher or your visualization has a much higher likelihood when playing with real data. If you're just using a JSON object and you get it to work, and like that's the data you plan on showing for the end of time, great. But if you're plugging into a live API, which is what to me one of the most exciting parts about actually doing these visualizations, is playing with real like live data sets that can be interacted and played with. Being able to have mapping functions that will turn a particular data set into something that can be visualized in a new way is, and having these libraries that are optimized to the hilt, because this, I mean, I don't exactly know how he's doing these calculations, but I know Stack, what it's going to do is it's going to take a bunch of Y plots and it's going to place them on top of each other. And it works. So we have a basic plot, and as you can see before, I'm mousing over to actually show, like, if we go back to the data that we showed in the example, we had, so what we agreed on the API was, and this is a good practice, we had portfolios for these two different sections, and I've massively dumbed down the data so we can read it on a screen. Well, not dumbed it down, simplified it. And you can see that we have two portfolio positions with actually showing the aggregates of the actual positions. So one of the first simple requirements is what a more complex interaction that the client wanted the app needed to do was when you moused over a particular section of the a particular position, you wanted to be able to drill down and see more, like actually what the positions that made it up. So this interaction is a pretty standard, was accomplished pretty easily, because all we had to do was instead of just trying to create an interaction, we simply created two plots on top of each other and had the mouse over for one plot just set an opacity on the one behind it. So all we literally have is just two plots sitting on top of each other. And it seems inefficient, but actually this has actually worked. We've used this kind of pattern several times. When you have layers of data that you want to show, you can literally just paint them one on top of the other. And then as you want interactions, you can have one section melt away and unfold the one behind it. So revealing, like, anytime you have way more data than you want to show. In this position, like, this is obviously just, you know, two positions with one with actually only two stocks in it. But the actual implementation had the implementation with the customer's data had hundreds of positions per portfolio. So trying to show all of that in one data set is an eyesore. So they needed a way to just drill in. And these kind of patterns are pretty easily set up if you just follow, and D3 has a pretty simple set of interactions that are, if anybody's used jQuery, and we've probably all touched these before, they have all the basic interactions you want for both mousing over, and they have ones that work on tablets as well. So for touch interactions, and getting both to work is on both devices is sometimes requires a little more work, but in the end, you can get any device to actually have the interactions you want. Okay, so the next part of this graph was one of the requirements. So one of the core requirements of the application was not just revealing more revealing more, but actually having the user, when they be able to not just view a position based on what the actual value of the assets was, but actually view it as a percentage. So you can see I'm just basically clicking on the graph to flip back and forth between the two. So with this interaction, it's pretty standard. You want to, it seemed like a pretty simple idea, but getting these kind of transitions to work is pretty trivial, because D3 has a great transitions library built into it based on click events. So you can actually just call the x-axis that we set up before, pass in our new actually just target it as a div, call our original x-axis that we defined a long time ago at the very top of our application, come back and reuse it completely again, and all we have to do is just call a new mapping function, a new area function. So instead of using the, excuse me, that's the wrong one. Instead of using the old area, which was we had an area plot, we use a second area plot that we've created. So this is simply the application that just paints the div with area that paints an area actually in the div. And instead of it being calibrated to absolutely show positions for max, what it's doing is it's calculating as a percentage based on aggregate, based on the actual complete values of all of the positions in a portfolio at one time. So I really like the idea of being able to a user to click on a specific piece of data, view it one way, and then view it another way. And this is just a really simple example doing that, but D3 is abound with examples of being able to take something and look at it in a new way with just a really simple interaction. And those little simple, that simple little act of hiding something can be a really powerful way to turn something that would not have, would just either, that would require juggling between two graphs or two visualizations, but being able to combine that into one and do it in a really elegant way. Being able to come to the client with ideas like this and or build these into their product, I think is one of the coolest parts of using this technology. So we have basic interactions. We have our margins set up, so we have some scaffolding code set up to be able to refer back to for axes, for scaling, for adding colors. But at the end, I said I was going to try to articulate something hard, which was actually telling a story with your data. So the story that they needed told, as I said earlier, was not just, they just didn't want to look at their portfolio positions. They actually wanted to know where did they want to be, what were their target allocations, and what were their actual allocations. Like, they had the live data for the actual, they just didn't know how to be able to view very quickly in a dashboard where they wanted to be versus where they were. So the simple way that we, one of the most obvious ways to approach this is just to provide an overlay. And this really simple example where the JSON data that they started providing us provided as target allocation. So you can see that they had a particular allocation. This is where they wanted the allocation to be for, and their minds they wanted to have an exact position of the portfolio as often as possible. And anytime they deviated from the data, they wanted to be able to visualize it so they can start thinking about, okay, when do we want to, try to shuffle these things around to create a better allocation. And all we had to do, just like before we created two plots and superimposed them, we just created a third plot with the data and just found because it's a scalar, it's an SVG, you can do some really nifty things with texturing and background. So this is just an opaque background. And it's just overlaid on top of the existing data. So a person can look at the overlay and very quickly see where they want to be and where they are different. So you see, all you have to, and it's really nice that you can use an SVG, create a pattern unit, an attribute, and what this does is it creates a div element in your actual DOM that is actually the overlay. And what it does is when you actually call your stack and paint your div element, instead of calling a normal background display, you call a URL that targets the div you created. So this, I'm actually using code to target the div in a later example. And what it does is it will pick up that texture pattern that you set up before and overlay it on top of the existing pattern, which I think, so these are the two defined textures, which are just cross-hatched, and then they're referred to with these div elements. The actual paths that are being drawn are referring to those, and then they use that texture and the color to be able to paint on top of each other. So now that we have the overlay and the thing on top of, what they really needed to do was not just look at the overlay or see the actual difference in the actual positions, but to be able to actually drill into the application that they were looking at, see the overlay, but actually change their overlay allocations. So this is actually hooked up to their API, so I just unhooked it from the API and put it into some DOM elements. But very simply, being able to change the allocation status from and re-render. You can take those particular SVGs and just really simply re-render them one on top of the other. So going from a story where they're actually viewing their applications, being able to render and see where their actual positions are, and then be able to contrast where they want to be. Even though it's very simple, putting all these things together and doing it in a way that's going to handle lots of data is something that we had like writing code that was readable and actually having like one thing building on top of each other and referring back to the right way is something that just paid a lot of dividends for us down the line. So that was like an example of a very basic interaction that we made for the client to show exactly how they needed to, like where the positions were, where they wanted to be, and in the end, the actions they could take to get a better result for when and how to rebalance their portfolio. So that's like the core codes part of the talk. And what I really want to articulate is that like actually creating something in D3 is not as super hard as I thought it was going to be. I was a little bit intimidated.
I actually have a question about the previous slide.
Yeah, go for it.
So, did you know anything about D3 initially before? It's not like you didn't, right?
I did.
Oh, you did?
But I mean, it's going from building charts and graphs to actually building things from scaffolding ground up.
So what was like sort of the ramp up time involved in order to like go from knowing almost nothing about D3 to building something like this?
Inside an Angular app? Just
maybe, or,
two.
doesn't have to be, but yeah.
I mean, it could be anywhere depending on your skill level. If you're intermediate, 2 months, a month. It's not incredibly hard. It's just the larger. It's getting it to play nice with other. I mean, if you're thinking about putting this inside of a larger application, it just kind of compounds the problem about getting things to render correctly. You throw tablet in there, or throw like a mobile web browser. There's a little more time. So each one of those steps kind of makes things a little more complicated. But if you want a visualization in a web browser and you want it standalone, I hate to put too fine a point on it, but that's about how long it took. So it's hard for me to like really pin it down, but that's how long it took. So thanks for listening. If kind of the summation of this slide is that I hope that I've really impressed on you that you can get started with D3 right away, and it's not as daunting as I first thought it was going to be. It's just a question of methodically like making code that reads like a book, and that's kind of like that's what we really talk about. Like that's really how we think about it when we try to write it, because it's being able for one person to pick up a visualization is for multiple people to be able to read each other's code and go through and add elements onto and interactions one on top of the other is something that is just really achievable with D3. So I'm going to open up for questions now. I've spent enough time blabbering, and I'll let, yeah.
Yeah, hey, do you recommend any like helper plugin built on top of D3 for getting started with basic?
Dimple.
Dimple.js
is. Say again? The question is, if you're using D3, are there any helper libraries that you can do that will get you started faster? And the answer to that is there's a library called Dimple I can recommend, Dimple.js. But everything you do, the best thing part about Dimple is that you can open up the source code and you can read it. It's small and concise, and it basically, it does that thing where you're like, huh, yeah, that's how I would have done it. Going back to what I said earlier, being able to build it from scratch has real value, because each component that you built, as you move down this application, each component that you built is something that when you're going to want to add a custom visualization onto, you're going to want to refer back to it. The axes methods that you set up, everything you want to refer back to, because if you want to add an interaction or you want something to change, you're going to need to have access to it to be able to say, hey, you repaint, or hey, you move across the screen. And it's every time you go into an example and want a custom interaction, they're going to be asking you to kind of stretch your skill level to be able to dive more deeply in the library to be able to do the things you want to do. And those libraries will sometimes extract things away. So the best ones are the ones where they'll get you started, but they aren't too much of a crutch. The lady in the middle.
So can high charts and D3 coexist? I thought that high charts was built on top of D3.
They can coexist, but one is highly abstracted on top of the other. So if you wanted to use them together, nothing would stop you, but it's kind of a choice of methodology. One is I'm going to choose this library and it's going to work, and the other one is I'm going to build it from scratch.
But isn't high chart built on top of D3? No?
It's not. Not to my knowledge.
So in D3 you end up a lot of time like writing very repetitive code about scaffolding your axis and scaffolding
Yep.
your other things. What do you think about the patterns for reusable components and reusable charts? And
You probably picked up I used vars a whole lot over and over and over again. Reusability versus readability is a hard trade-off in this particular library because once again, you remember I kept going back. We have to scroll back up and access this thing we've done before. And every time you abstract away parts of the visualization, that going back and referring becomes a little more difficult and obscured. So if you know that these scaffolding elements are going to be used over and over and over again, and you know exactly what to return, absolutely abstract away.
But how about, for example, if you have 2 charts on one page or 5 charts on one page, kind of reusing common components, like, oh, I know my axes are going to be all the same because I styled my axis one way.
Yeah, so we use something called services in D3, which are it's just like creating like a scoped variable that you can access over and over and over again to be able to get a service. And we use that for the axes, but we started trying to do that for the color components and other things. But we quickly found that each visualization needed something a little bit different, and we ended up refactoring the services so often that it was just like we kind of had to be more selective about dumping them and being like, you know, this. We reuse this over and over again, but we reuse it in too many different ways that, you know, creating parameters each time we needed the color, you know, to use a different type or version of the API, because the D3 API is large. There's something for everyone in there, which makes it fun, but it also makes it a learning adventure every day. Sir, in the front.
Can we customize the colors based on the data range?
You can customize them on the range, and you can set predefined ones. So if you go to the D3 library, there's like there's like a set stock one for 20, 30, and 40, but you can actually build custom. There are really great patterns for custom functions that will just rip right across the color table for you, and that's one of the sweetest things about it, I think. In the back, sir.
Have you ever used cross filter? And if so, like, what do you think about it, or what role does it play?
Are you talking about the square?
Yeah.
Yeah. Cross filter, to be honest, all I could say is it looks really cool, but it's some highly optimized JavaScript, and it's on my list of things to crack open and go through. So the actual cross filter is a library for how would I say it? It's an algorithm, a JavaScript, highly optimized JavaScript algorithm for like iterating through data and looking for comparisons. So they used it to do flight chart analysis. But the visualization side of it is they took the result of their library and they painted it. And what they did have is, as I said before, they had multiple pages. So they were showing flight times versus delay times. So they had all these data, and as you were filtering, it was able to show one versus the other. So that's some context for everyone. And he's asking about my opinions. Those kind of visualizations, I think, are going to become more and more important for financial institutions, because someone would have to be able to show that, articulate it to another human being. You'd have to write a report, and it would take months. Where you can just show that to someone and say, play with this, and it just becomes really obvious. Like, in what Ad answered is you really can quickly drill down and say what airlines are late and what and when, and you can look for cohorts of those kinds of things and kind of just intuitively find them.
DCJS is a library that combines both. That exists. It's really easy to use. I didn't even know D3 like 2 months ago, and I started with D3 cross filter, and it's been great. So it's worth looking at if you're curious about either.
What was the name of it again?
It's DC.js.
DC.js. Thank you. Sir in the aisle.
You're saying that you're using D3 to pick the colors for your charts. How do you enforce a situation where you want the same color to represent the same entity once the data chart changes?
That actually got cut from the presentation for brevity, but there was a library that I can show, or it was a Stack Overflow answer that turned into a GitHub page that actually iterated through a color chart and like selected them based on, it just had a way of saying I want things between these ranges in like blue and what we were using it for was portfolios, was like colors to say like this is the master color, we want something to be drilled down in a specific color range. It was the function and the style that had a callback for each individual render. Does that make sense?
Saying that I would like to see the same color represented in the same name of the portfolio, for example, tomorrow.
Oh, so everything is based on, so everything as your data is iterated through document, it's D3 iterates through data and paints div elements, 1, 2, 3. That color selector works upon position in your data in the array. So what you'd have to do is I should have been more specific about that in the presentation. Controlling like how your data comes through, and if your backend team kind of switches up the data on you, like they're like, oh, today we're gonna sort it by number instead of alphabetically, because that's just what we're gonna do today, it will break your visualizations very quickly. You have to be highly structured about how data is put in JSON, and switching SQL queries up and things like that will break your visualizations.
So you can't specify a color to override.
You can. It's endlessly flexible. You can do whatever. You can specify whatever color you like, or how colors are selected.
Coming to this question, let's say the data, right? The data value keeps changing. Let's say I'm doing top 10, right? Today the top 10 will be one value. Tomorrow it will be other value. But if you want the same color to the same value, is it possible?
Yes. So
You said it's based on index, but index changes.
I'm gonna let everything wrap up, and then we can take questions at the front. Thanks everyone for coming. It was really informative.